So today we're going to be having another look at line graphs. So the first question we have is, what was the difference between rainfall in October between Dublin and Paris? So we have a look down the vertical axis. We'll see the rainfall is in millimeters, and the horizontal axis at the bottom there are the months of the year. The blue line represents Dublin, the red line represents Paris. So as it's all to do with October, I need to go along the axis to find October, and there I've highlighted it for us with a blue arrow to represent Dublin in October, and the red arrow to point towards Paris in October. So what I have to do is to look where the dot is opposite October, and then take it along to the vertical axis. So we go left along that line, and when we see towards the end, it says 80 on it. Similarly, we do the same thing. We find out where the red dot is on October and take the line up to the axis, and we see that says 20. And if it's difference, then we have to find the difference in between 80 and 20, which is 60. And of course, we need to put the unit, which is millimeters. This is another type of question that we might get, a problem-solving question. Jenna reached a higher top speed than Max in a car race. Which line represents Jenna's performance? So the title, speed of cars during a race. On the vertical axis, we've got speed in miles an hour, and along the horizontal axis, we've got the time in seconds. So having a look, both cars decide to take off and go for a drive and go at different speeds, but I want to know which of these colours represents Jenna's performance. What I've got to do is to find a higher top speed. So if I look on the graphs and see which has got the number that represents the highest, and there's the arrow pointed to where it is. That dot there represents the highest speed, so obviously it's the orange line that has the highest speed, and therefore the orange line represents Jenna's performance. Finally, we've got a reasoning question. Mo thinks that the heating timer is set to come on at 1 p.m. and 6 p.m. Is he correct? Explain why. The title is Temperature Mo's House. The vertical axis on the left is temperature in degrees Celsius. But on the bottom we've got the time, but that's in 24-hour clock, which is what's going to be a bit more problematic. So the first thing we need to do is to work out where those times are on the graph. So I'm going to convert between 24-hour clock and 12-hour clock, because obviously we can't have them in difference, and because the graph says 24 hours, that's where we'll go. So 1 p.m. is 1300 hours, 6 p.m. is 1800 hours. I'm going to put those dots, those arrows on the line to represent the times. So if we have a look at what's happening in the graph at 1 o'clock, yep, it certainly is going up, but it started going up earlier than that. And if we have a look at 6 o'clock, 1800 hours, you'll see that the temperature doesn't change at all. So I think we can say definitely the Mo is not correct, and if we look again at the graph, the times that the heating does come on appears to be at 1200 hours, 12 o'clock p.m., and 2000 hours, which is 8 p.m.